So probability distributions can also be described in terms of their mean and their standard deviation. So we spent a lot of time over the last couple of weeks talking about how to calculate the mean and standard deviation for samples. And when we talked about the mean and standard deviation in samples, we called the mean x bar and we called the standard deviation s. And we referred to these as sample statistics. In a probability distribution or in a population, we refer to the mean using the Greek letter mu, and we refer to the standard deviation using the Greek letter sigma. This is annoying for beginning students of statistics because it seems like we're just throwing more letters at you for no reason, but these are conventions in statistics, so we're going to use them here as well. And we refer to the mean and standard deviation in a probability distribution as parameters. Now, I just want to give you an example of what I mean by mean and standard deviation in a probability distribution. So when we talked about frequency distributions, we talked about how you can calculate mean and standard deviation for a frequency distribution that's shown in a frequency table. For data that's shown in a frequency table. So before we had some examples of other variables and we calculated the mean and standard deviation for them. So what I'm showing here is just the mean and standard deviation that I calculated for this data. So these are the same coin flips that I just did on that last page there. So when I did the double coin flip 10 times, I had 0 heads come up 1 time, I had 1 heads come up 6 times, I had 2 heads come up 3 times, for a total of 10 events, so 10 of those double coin flips. And if you calculate the mean for this data, so if you add up your 1 0, your 6 1s, your 3 2s, and then divide by 10, you come out to a mean of 1.2. So the average value that I got in this data, these 10 different observations, my average is 1.2. For those 10 different observations, you can also calculate a standard deviation. And if you do that, you get a standard deviation of 0.63. So what I'm talking about right now is the same thing that we were doing over the last couple of weeks. So I have 10 different observations, again, 1 0, 6 1s, and 3 2s, and I calculated a mean and I calculated a standard deviation for them. This is that the average value I got from my double coin flips was 1.2, and there was a spread of an average distance from the mean for all these observations of 0.63 away from that mean of 1.2. So that should all be familiar. The thing is, you can also talk about the mean and standard deviation for a probability distribution. And here I'm referring to them using mu and sigma, which are our mean and standard deviation when talking about probability distributions. And here, we're not going to talk about how to calculate these. These are calculated for formulas for something called a binomial distribution that you don't need to know about. But these are the mean and standard deviation for the probability distribution that's written up there. And how these are interpreted is that if you are to take a sample based on this probability distribution, so a sample like you see on the left side under frequency distributions, you would expect that sample to have a mean of about 1. You would expect that sample to have a mean of about 0.71. So again, on probability distributions, these parameters are the values that you would expect if you were to take a sample. And so if you take a look at them, the sample mean came out to 1.2, and that's pretty close to the mean we would have expected based on our probability distribution mean. So it's not exact, that's because of random variation in sampling, but we got a sample mean of 1.2 when we were expecting a mean of 1. Same thing, our standard deviation is similar. We got a standard deviation of 0.63 when we were expecting a standard deviation of 0.71. So a little bit different because of random variation in sampling, but pretty close. And in general, just like a probability distribution tells you what percentage of different outcomes you would expect to see in your sample, it also tells you the statistics that you would expect to find in your sample for mean and standard deviation. And the takeaway from this slide is just that probability distributions for numerical values have means and standard deviations, and that you'd expect the mean and standard deviation of your sample to resemble the mean and standard deviation of your probability distribution. And this is something that will also be important later, but that's really all I'm going to talk about it for now. The last item on the agenda for today is graphing probability distributions. And here I'm going to show an example for graphing the probability distribution for our double coin flips. And I'm going to go over to the document camera to do that, but before I do, I'll just note that we're going to see all the bars add up to 1. You'll see what that means in a second. But I want you to think about it as the area under the graph as I'm doing it. So we're going to go over there now, we're going to graph it, and we're going to talk about what the area in the graph means.